Okay, so if you haven't yet grabbed these notes, these are day 18. And thankfully, Miss Ulaga taught this yesterday and found all my posts. So, it's a good day. Okay, so we have a line, which is graph. Awesome. So then we have all these new terms. Oh, actually, only 2 of them are new. In behavior, have you done in behavior before? Count for one long time ago? Probably not. Okay. So the left in behavior is a statement that describes the values of y as the x values get smaller. So you're talking about the left-hand side of your graph. The in behavior is describing the values of y as your x values get smaller. You're going to see a lot of arrows, and that means approach. So an arrow pointed to the right means approach. Okay, so if you look at the graph at the top of your page, you can't see it on my slide anymore, but what is happening to the y values on the left side of your graph? So way over on the left, what's happening to the y values? They're increasing forever and ever, right? So as we go to the left, as x gets really, really close to negative infinity, your y values are going to get bigger, and they're going to approach positive infinity. So for the linear function pictured at the top of the page, as x approaches negative infinity, f of x or y approaches positive infinity. So it's going up forever and ever to the left. And then every time you talk about in behavior, you have 2 statements, because you're talking about the left-hand side in behavior and the right-hand side in behavior. On the right-hand side, it's talking about the values of y as x values get larger. So that's what happens on the right side of your graph, is your x values get larger. So your in behavior is describing the values of y as your x values get larger. Okay, so the right in behavior for our line, what's happening on the right-hand side of your graph? What are your y values doing? They're decreasing, so they're getting closer and closer to negative infinity. As x approaches positive infinity on the right-hand side, f of x is going to approach negative infinity. So the only thing that you're ever going to have to change in this statement are these last 2 things. The beginning part is always going to be the same for left and always going to be the same for right. Okay, so what's the slope of that line?
Negative 2/3.
Negative 2/3. How'd you get that? Anybody?
the point.
Yep.
And then I drew a line to
Mhm.
the next point.
Yep.
And I just did up and down, kind of like a right triangle.
Yep, so what do you know about slope? What is slope?
Right, so this one.
Rise over run. Okay, so don't answer this next one. Okay, so which values are we talking about when we're talking about rise? Are we talking about x values or y values? Y values. And when we're talking about run, are we talking about x values or y values? X values. So it's the change in y over the change in x, right? Rise over run. Okay, we have this delta symbol, delta y divided by delta x. All that delta means, that triangle, it doesn't mean triangle anymore. We're past geometry. Now it means change. It's the change in y over the change in x. But it's still slope, still rise over run, still the things you know. Okay? When we talk about the equation of a line, what's the first equation of a line that pops into your head? What? Slope-intercept form, y equals mx plus b, right? Okay, for some reason, Mark Sparks likes to use a and b instead of m and b, but it means the same thing. So f of x equals ax plus b, where a is your slope and b is your y-intercept. Okay, so the equation of that line up there at the top, Blake told us that the slope was negative 2/3. What's the y-intercept? Positive 2. So the equation of the line is f of x equals negative 2/3 x plus 2. Okay, and then have you talked about zeros of a function before? Okay, a zero of a function is the value of x when y or f of x is 0. It's your x-intercept. For some reason, there are like 4 or 5 different names for x-intercepts. I don't know why. I like to call them all kinds of different things, but all a 0 is an x-intercept. So what's the x-intercept of that line up there at the top of your page?
3.
Yes. So the value from the graph is 3. If you were trying to find it algebraically, you would set your equation equal to 0. So negative 2/3 x plus 2 equals 0. And then you would solve for x. You would subtract 2, multiply by 3, and divide by negative 2. To get your 0, x equals negative 3. Okay, so now we have a new function f of x. They give us some points, so a numerical representation. We have a graph where we can graph it. And then analytical really just means algebraically. How are we going to talk about this graph? Okay? So you have a table underneath. It says first identify the slope of f of x. And then on the table show why this is the slope no matter what 2 points are used. Okay? So we're gonna use the table. And we said slope was the change in what over the change in what? Change in y over the change in x. So I'm just gonna pick the first 2 points. What's my change in y? -5. We're subtracting 5 to get from 8 to 3. So what's my change in x? +4. So the slope is going to be the change in y, which is -5, over the change in x, which was +4. This will go in that first box underneath. Is there anywhere on the table where it's not a change by 5 in the y value and a change in 4 in the x value? Are they all the same? Shaking your head no. Which one is different? Yes, these last two. To go from -7 to -9.5, you subtract 2.5. To get from 6 to 8, you add 2. But is that the same thing as -5 over 4? Why? It's the same ratio. Yep. 2.5 or -2.5 over 2 is the same thing as -5 over 4. It's the same ratio. Okay, so now let's graph it. We're going to graph it simply based off those points in the table. So if you haven't already, go ahead and plot those points and then connect them. Okay, so now we have our graph, and analytical is talking about the equation. Do I have the equation of this line yet? Nope, I do not, but I do have the slope, right? So I can set it up as f of x equals -5 over 4x plus b, where b is the y-intercept. Is that an easy y-intercept to figure out? Like, can I just look at the graph and pick it? Sadly, no. So how can I solve for it? Anybody have an idea? Yes.
Plug the f times 10 through x and 1.
Yep. Plug in the point. Does it matter which one?
No.
Nope. Pick your favorite, plug it in, and then solve for b. So I use the point -6, 8. And -5/4 times -6 is positive 15 over 2. When you subtract that from both sides, 8 can be rewritten as 16 over 2. 16 minus 15 is 1/2. Or you can write it as a decimal. Our y-intercept is 1/2, or 0.5. So the equation of the line is f of x equals negative 5/4 x plus 1/2. Okay, so we already identified the slope as negative 5/4. What's going to be my left end behavior? As x approaches negative infinity on the left, what does y approach? Positive infinity. On the right-hand side, as x approaches positive infinity, y approaches, what? Negative infinity. Okay, then it says between which two x values in the table does the zero of the function lie, and give a reason. So what did we say a zero was? It's an x-intercept. Okay, so what two values in our table are around the x-intercept? What?
0 to 1.
That's on the graph, yes, but on the table. So she said between 0 and 1, which is right, which we can see from the graph, but from the table, which two values? Negative 2 and 2. Why? Anybody? Why is the 0 between those? If you didn't have the graph. What's your y value of your x-intercept?
Because -2 is the smallest negative, and then +2 is the smallest positive, the closest to 0.
Okay. I was gonna go with the y values change
Oh,
from positive to negative, but I mean, that works too. So it's somewhere between -2 and +2 on the table, because the y values change from positive to negative, which means your graph has to go from above the x-axis to below the x-axis, and there's an x-intercept in there somewhere. I think we talked a little bit about that in the last unit. All my days are running together. Welcome back. Okay, so now that we know about where the x-intercept is going to be, where the 0 is, we're going to use our equation to find that 0. We want to find the exact number that the 0 is at. So we're going to set our equation that we found above this equal to 0. So negative 5/4 x plus 1/2 equal to 0. And then solve for x. So like me, you really need fractions, you can multiply everything by 4. Make the fractions go away. So hopefully you got the 0 as x equals 2/5. Okay, is that x value between -2 and +2? Does it look like it's about 2/5 on the graph we drew earlier? Yeah, always double check yourself. Okay. Lastly, identify the intervals where f of x is greater than 0 and the intervals where f of x is less than 0. Okay, so the interval where f of x is greater than 0, is that going to be to the right of our 0 or to the left of our 0? To the left. Why? It's above the x-axis. So for negative infinity up to 2/5 on the x-axis, all of your y values are greater than 0, which means everything from 2/5 to positive infinity is going to be below the x-axis or less than 0. Okay, so this one was nice because we have the graph to help us. But on the next two, we don't have a graph. So I want you to go ahead and try to answer as much as you can on that next example. Number 2, do the slope, the end behavior equation, and zeros. If you want to work with your neighbor, you can. Just on number 2. We'll take 5 minutes. Okay, so hopefully you got that the slope was 3/2. Because your y values go up by 3 for every time your x values go up by 2. So if it's a positive slope, it's going to go up from left to right, correct? Okay, so that means if your line is going up from left to right, on the left-hand side of your graph, your y values are going to approach what? Negative infinity. And on the right-hand side, they're going to approach positive infinity. So your left hand, as x approaches negative infinity, g of x approaches negative infinity. And on the right, as x approaches positive infinity, g of x approaches positive infinity. When you go to find the equation, again, they did not give us the y-intercept. So you have g of x equals your slope of 3/2 plus b, or x plus b, sorry. You can take any xy point you want to plug in for x and y. So I picked the first one, -9 and -5. Then you get to solve for that. Hopefully you got b is 8.5 or 19/2. So your equation g of x is g of x equals 3/2x plus 8.5 or 19/2. lucky number 2. Okay, and then just like on the last one, between which two x values in the table does the 0 of the function lie? Well, your y values change from negative to positive between these 2 points. So between x equals -7 and x equals -5, because your y values change from negative to positive, which means your graph goes from below the x-axis to above the x-axis. And then I'm going to stop for a minute, and if you haven't already, go ahead and find the the 0 of the function using your equation, or my equation. Hopefully in all your math you got that x is -17/3, which is about -5.7. Is that between -7 and -5? Yep, there it is. And again, I'm going to give you some time, probably 5 minutes again, to work that next one. Okay.
Very precise.
So hopefully you got that your slope was -1/2. So your left in behavior goes to positive infinity, and on the right it goes to negative infinity. Your y-intercept is -1. So your equation is h of x equals -1/2 x minus 1. So it says between which two x values in the table does the 0 of the function lie? Well, in the table it tells you exactly what your your 0 or your x-intercept is at -2, because a 0 will have a y value of 0, and that's like -2, 0 is in the table. So if you showed that graphically, or algebraically, sorry, not graphically, you would set it equal to 0 and solve for x. You get x equals -2. You also did not have to do all of this work right here to find your y-intercept, because they give it to you in the table. But if you wanted to, you could. Okay, on the next page, we get to do this from a graph, which is wonderful. so much easier than from a table. Okay, so they give us the graph of this line. And they're asking us questions about this graph. So what's the slope of this line? 2/3. We rise 2 and run 3, so the slope is 2/3. Someone other than Ashley, what's my y-intercept?
-2.
-2. Okay, so my equation in this case, is y equals 2/3 x minus 2. You could also have f of x or g of x or h of x equals, since they didn't specify, I just left it as y. Okay, what's the end behavior on the left-hand side of the graph? As x approaches negative infinity, f of x or y approaches negative infinity. And on the right-hand side, as x approaches positive infinity, y approaches positive infinity. And the zero of the function is x equals what? Great. Okay, go ahead and do those next two. Okay, go ahead and check your number 5 with mine. And number 6. Any questions so far? Feeling pretty good about graphing lines? And most of this is review. Okay, so it says the linear functions below are expressed analytically, aka they give you an equation. Determine the slope of each function, identify the end behavior, then sketch a graph. Okay, so what's the slope of g of x? -2/3, because it's in slope-intercept form. If the slope is negative, that means it's going to go down from left to right. So my left end behavior, as x approaches negative infinity, g of x approaches what? Positive infinity on the left. And on the right, it's gonna approach negative. Yes. Okay, then go ahead and sketch your graph. Okay, once it's graphed, is it easy to find the zero of the function? Does it cross at like an even number in the corner of a box? No. So to find the zero of the function, you could probably guess it from the graph, but they're not always going to be so easy to guess. So just like we did a few pages ago, we're going to set it equal to 0. So set your equation equal to 0 and solve. So that would subtract 3. And then multiply both sides by 3. And divide by -2. But I have that one. Okay, and just review of linear functions. We just have this new fun left and right end behavior. So go ahead and take the next 5-10 minutes to work those last 2 examples. Okay, so I'm going to go ahead and put up my answer key for my paper with all the work shown, because all the work wasn't shown on the slides. Okay, so when you get finished, use the last 15 minutes we have until lunch to work on the day 18 homework. And then after lunch, we're going to do free response number 15 together. Or actually, I'll let you do it and we'll go over it together. But so for now, go ahead and work on that green day 18 homework. And then after lunch, we'll do free response 15. We're working on free response 15. Okay. Now let's go over it. So linear function g of x is represented by the table of values pictured below. Use the information in the table to answer the questions. So we're going to state the left and right end behaviors of the graph of g of x. So this part was 2 points. You get a point for the left side As x approaches negative infinity, g of x approaches positive infinity. And another point for the right end behavior. As x approaches infinity, g of x approaches negative infinity. Pretty straightforward. Part B, find the missing function value in the table. Show your work or explain how you determine that value using the slope of the function. So this was 3 points. You correctly find a slope of -2. You write the correct equation. And then you plug in -1 to get your missing value of 5. Okay. Part C, between what two x values in the table does the 0 of g of x lie? And justify. So g of 0 is 3, g of 3 is -3, which means the graph goes from being above the x-axis at x equals 0 to below at x equals 3. So the 0 must be somewhere between 0 and 3. 2 points for that one. And last but not least, part D. Use the equation to determine the interval of values along the x-axis such that g of x is greater than or equal to 0. That is your result. Verify your response to part C. So you set g of x to be greater than or equal to 0 and solve it correctly. So less than or equal to 3/2 gives you the interval from -infinity to 3.5, or 3/2, sorry. And then an explanation of g of x equals 0 when x is 3/2. So that's between x equals 0 and x equals 3. Okay, so spend your last 5 minutes, 10 minutes? I don't know how much time, 5 minutes. And finish up that green paper, day 18 homework. We'll turn that in next time.